All right, in this video we are going to look at how to find the equation of a power function through 2 points. Hopefully you've already watched the exponential function video. This one is very similar to that. The process it starts out a lot like that, with one big difference that we need to use logs to solve this. So hopefully you have a little exposure to logarithms from Algebra 2. If not, I will tell you the two little tricks that you need to know about logarithms to be able to solve this thing. So again, we're trying to find the equation of a power function. So I have my general equation for a power function is y equals, again, it's either a times b to the x or a times x to the b. For power functions, the x is in the base and the constant is up in that power there. So it's going to be a times x to the b power. And we're going to start this the exact same way that we did with the exponential functions. We're going to create two equations, create a system of equations, right, using the 2 points I know. So system of equations using the given points. So I'll use the point 5, 225. So we have, it's y equals a times x to the b, and I'm just going to substitute. I know that y is 225. I know that x is 5. And I'll do the same thing for the point 2, 14.4. My y is 14.4. A times x is 2 to the b power. So again, just like my system of equations for the exponentials, I have two equations with two unknowns, so I should be able to solve for both of those unknowns if I can figure out how to get rid of one of the two. And again, just like exponentials, my next step is the exact same. I'm going to divide one equation by the other. Right. Because this will cancel my a value. So I write that top equation at 225 equals a times 5 to the b power. Again, you could think of this first as dividing both sides of this equation by 14.4, right? Like I can do that. I have an equation that's balanced, and if I divide both sides by the same number, the equation is going to stay balanced, but 14.4 is equivalent to a times 2 to the b. I'm saying that those two things are also equal. So I can just basically divide these two equations, one by the other, right? Left side by the number, right side by the variables, because that is going to cancel my a value there, right? So 225 divided by 14.4, if you trust me to be your calculator, I get 15.625 equals a divided by a makes 1 times, and then I have this 5 to the b divided by 2 to the b, right? So this you have to do a little bit of, right, like the rules of algebra. If you have, right, rules of exponents for algebra, if you have a to the x divided by b to the x, that is equivalent to saying I have a divided by b to the x power. You probably all saw it instead as like, right, if you have x over y to the a power, that is equal to x to the a over y to the a, right? I can work both ways, backwards and forwards. You're usually used to seeing it go the other way, right? But we can also split this up. So this 5 to the b divided by 2 to the b, that becomes 0.625, just becomes 5 halves to the b power, or 2.5 to the b, right? 15.625 equals 2.5 to the power of this unknown variable. So again, divide to cancel the a's, so I get rid of those to get this thing where I have one equation with one unknown, right? But this is a little trickier because my unknown here is in the exponent, right? That b value is up in the exponent. So to get it out, we need to use logs, right? We need to use logs to get it out. And there are two different ways that you can do this. One is, right, and depending on what you were exposed to in Algebra 2, you can pick one way or the other, right? One feature is to use this property of logs that says if I have, right, if I have the log of a to the b power, that is equivalent to being able to write this as b times the log of a. That b just comes right out front there, right? So that basically will let me bring the b and bring it so it's not in the exponent. It's just this multiplying factor now. Or another way that you could do this is just to totally rewrite it, right? If I have like a equals b to the c power, which is basically right, we have some number equals some number to some other exponent, that is equivalent to rewriting this as the log base b of a equals c, right? So those just switch. The b, the base stays the same, right? Of this answer is equal to this exponent, right? Comes out front. So yeah, we'll look at either way. If one of those rings a bell, you can pick it. So I'll do the first way first. Okay. I have my equation 15.625 equals 2.5 to the b power, and I'm just going to take the log of both sides, right, to get this thing out. So I end up with the log of 15.625 is equal to the log of 2.5 to the b power. But now I have this, right? The log of some value to some other exponent. I could just bring that b out front. This becomes the log of 15.625 is equal to b times the log of 2.5. And this is just a number, right? It would just be like saying I had like b times 3. How do you undo that multiplication? Now I just divide, right? So divide both sides by the log of 2.5. And that's going to cancel there, and I'll get b by itself. So my b value is equal to the log of 15.625 divided by the log of 2.5. Plug that into your calculator. You'll get 3. Right. Again, you could do the other way, just use the definition of what a logarithm is. Right. So that's just an alternate. I can start with the same thing, 15.625 equals 2.5 to the b power. I have this form, and I can convert it to this logarithmic form. My base stays the same, so this I could just rewrite. It's synonymous with log base 2.5 of my answer here, 15.625 equals, and my b just pops out by itself, right? Like this. That's just one step there, basically, to rewrite it. And if you have a calculator that can do a base formula, which Desmos conveniently can, right? So if I go here, open up a Desmos, I can just quick show you where this is. But if you type, whoa, man. Let's see if I can figure this out quick enough. Yeah. So if you hit the little like show keypad there. It's just one of the functions. In the miscellaneous, right, this is where you find the logs, right? So if you were doing the other method, I could do just the log of 15.625, close your parentheses, divided by, or doing this, you get this log base. Okay. So if I want to do the log base 2.5 of 15.625, I get 3 that way too. So you can use that method if you would like. Right. But again, now we're easy peasy lemon squeezy after this. I know what my b is. I just need to plug that back in, right, to one of the equations from above. Any of them work, right? B is this. I just need to go back to one where a still existed. So let's do the one without the decimals. 225 equals a times 5 to the b. 225 a times 5 to the b. But now I know what my b is. B is 3. So 225 was a times 5 cubed. 5 cubed is 125. To get a by itself, just divide both sides by 125 and I get 1.8 equals my a value. So now I have my a and my b in that general equation. Y equals, it was a times x to the b power. Just plug them in. Y equals 1.8 times x cubed. You go into Desmos, it should go through those first 2 points right up there. So good luck.